Have you ever stood by the sea and watched a truly massive ship glide past? It is a sight that fills the mind with wonder. These giants of the ocean, some as long as 4 football fields laid end to end, seem almost impossible. They are like floating cities, carrying thousands of people or mountains of cargo across vast, empty waters. But where does such a colossal thing come from? It does not simply appear. A giant ship begins its life in a much smaller, quieter way. It starts not with a bang of hammers or a roar of engines, but with the quiet scratch of a pen on paper or the silent click of a mouse on a computer screen. It begins as a single line, a simple idea in a person's mind. This journey from an idea to a finished vessel is one of the most incredible stories of human making. It is a tale of careful planning, immense power, and remarkable teamwork. We will peel back the layers to see how these giants are born. Before any construction can begin, a ship must exist completely on paper, or more commonly today, inside a powerful computer. This is the design stage, a marvel of mathematics and imagination. A team of naval architects creates a detailed blueprint for the entire vessel. Thousands of drawings and calculations. They show everything: the curve of the bow as it cuts through the water, the precise location of every pipe, every wire, and every light switch. The goal is a design that is strong, stable, efficient, and safe. Hull shape determines how it moves through water. Less drag means less engine power and fuel. Designs are tested in calm seas and giant storm waves. Center of gravity and ballast tanks ensure stability. A ship must be made of materials that withstand the ocean. For centuries, that material was wood. Today, we need more strength. The king of shipbuilding materials is steel, an alloy of iron and a small amount of carbon. Strong, relatively inexpensive, and workable. Enormous plates form hulls and decks. Extra thickness where strength is critical. Shipyards receive huge flat plates and long beams. Some plates are bust-sized and weigh many tons. Before use, they must be protected from rust, water, and salt. Shot blasting cleans the surface. Primer paint coats immediately after. This helps ships last 20 to 30 years. Aluminum, lighter but costlier and weaker, is used up high. A careful trade-off of weight, cost, and strength. Advanced composites like carbon fiber bring strength with low weight. Used in parts today, pushing marine engineering forward. The first and most important part built is the hull, the ship's body and skeleton. It keeps the ocean out and holds everything together. Giant plates are cut to precise shapes from digital blueprints. Computer-controlled torches slice with incredible accuracy. Plates are heated and pressed into graceful curves, especially at the bow. Welders fuse pieces into a single strong structure. Electric arcs melt plate edges and bond them as strong as the steel. Small sections become panels. Panels become hull. Every weld is inspected with X-rays and ultrasonics for hidden flaws. Quality must be perfect. Inside, massive beams and frames run length and width, like ribs. They resist ocean pressure and cargo weight. Bulkheads form watertight compartments to contain flooding. That is how the skeleton gains its strength and shape. Building everything in place would be slow and difficult. Modern yards use block or modular construction. Many parts are built at the same time in different shops. Each block can be enormous, sometimes a mini-ship. Blocks might be engine spaces or stacks of cabins, weighing hundreds or thousands of tons. Inside protected workshops, teams build and outfit blocks. Pipes for water, fuel, and waste. Miles of cables for power and communications. Ventilation, floors, insulation, sinks, and lights go in. Access is easy, so work is faster and safer. Meanwhile, the dry dock, the giant bathtub, is prepared. Its massive gate can let the sea in or keep it out. Enormous transporters and cranes move house-sized sections. The first block, usually midship bottom, is set precisely. Blocks are aligned and welded, sides, bow, stern. Soon, the boxes become a ship. Joined blocks form an empty steel shell. Next, we give it a heart, the main engine, a brain, the bridge, a nervous system, pipes and cables. A ship's engine can be 4 stories tall and thousands of tons. It is installed early. The ship is built around it. Connecting it demands extreme precision. A long steel shaft runs from engine through the stern to the propeller outside. Propeller blades are masterpieces of hydrodynamics. Alignment to fractions of a millimeter prevents vibration and damage. Generators power lights, computers, and systems. Pipes and cables, veins and nerves thread the ship. Fuel, fresh water, steam, and seawater for cooling and ballast. Cables reach the bridge, hallways, pumps, and offices. Everything is labeled and secured. Above, the superstructure rises. Living quarters and the bridge with radar, GPS, depth sounders, and controls. After months or years, launch day arrives. A moment of pride and excitement. For large ships, floating out is common and controlled. Hull sealing is verified. Water floods the dock slowly. The ship gently floats for the first time. Tugs guide her into open water. Older slipway launches slide ships down an incline. Supports are pulled. The cradle releases. Dramatic but stressful on structure, so rarer for the biggest ships. Launch ends dry dock work and begins outfitting. Cabins, furniture, final paint, electrical and plumbing connections follow. Soon it looks complete. But one more trial remains. Now comes the ship's final exam at sea. Sea trials prove the ship works as designed. Yard teams, owners, and safety societies go aboard, first time under her own power. Main engine to full power to hit contract speed. Fuel use measured at multiple speeds. Emergency maneuvers, full ahead to full astern, test, stopping distance. Vibrations are monitored. Navigation, steering, and turning circle verified. Autopilot and rudders tested to extremes. Bridge electronics checked. Radar, GPS, depth sounders. Every switch, lever, and button is verified. Safety first. Alarms triggered. Emergency generators auto-start. Lifeboat systems and drills run as in real emergencies. If issues arise, builders adjust and retest. When the ship passes, she is ready for delivery. After successful trials, the ship is handed over. A journey from a single line to a living vessel. A new giant begins its life. For 20 to 30 years, it will serve across the oceans. It might carry goods, host vacations, or transport energy safely. Thousands of people make it possible. Designers dream, engineers calculate, welders join steel, electricians wire systems, painters protect the hull. The yard coordinates a colossal ballet of work. In port or on the horizon, remember the journey to get there. From roaring furnaces to bright sparks and towering cranes, to careful hands installing a powerful heart. Ships are steel bridges connecting lands and cultures. A simple idea, with skill, teamwork, and persistence, becomes something strong enough to face the sea and win. Every giant you see began as a single line, drawn, simulated, cut, welded, assembled, launched, heart running, brain thinking, nerves humming. Built by many hands, together, and then the sea makes room for a new giant. How ships are made. Design, materials, hull, blocks, machinery, launch, trials, world, from a line on paper to a line across the ocean. Let's begin. Chapter 1. From a single line.